Today we will learn how to compute a determinant of a matrix. What is a determinant? First of all, we can compute the determinant of a square matrix. So we should have an n by n matrix. So we should have a square matrix, and it is defined by determinant of A is defined by the summation I from 1 to n aij cij, where cij, okay, maybe I will write here, so where the cij is the cofactor of aij, defined by it is defined by minus 1 to the power I plus j, mij, and mij is the minor of the matrix A, so it is obtained from A by eliminating row I and column j of the matrix A, and the determinant is denoted by determinant A or absolute value of A. So we denote it like this. Okay, let me give an example, so I think you will understand better. So okay, compute determinant of A, where A is given as this matrix 1 0 2 minus 2 1 3 4 minus 1 4. So this is a 3 by 3 matrix. So it is a square matrix, and we will choose j equal to 2. So ij, so I stands for I here stands for a row, and j stands for column, remember, and we choose the second column. Then using the second column we can compute determinant of A by using the formula says I goes from 1 to n, and A is a n by n matrix, so we have 3 by 3 matrix, so I is from 1 to 3 in this case. A ij and cij, but we choose j to be 2, so ci2. So what is the determinant? Determinant is a12 c12 plus a22 c22 plus a32 c32. Okay, I'm using the formula to compute c12. So what was it? It was minus 1 to the power I plus j. I is 1 here, j is 2 here, 1 plus 2, m 1 2. What is m 1 2? So we say we obtain it by eliminating row I and column j from A. So we will eliminate first row and second column. So like this, first row and second column. Let me. So we will eliminate first row, second column. So we have minus 1 to the power 3. So we have minus 1. And we delete first row and second column. We have minus 2 3 4 4. So we will calculate determinants in this case. Okay, but let's do c22 minus 1 to the power 2 plus 2 m22. So this is minus 1 to the power 4. So it is 1. So this time we will second row, we always eliminate second column. Second row, second column, we are left with 1, 2, 4, 4. So M22 is 1, 2, 4, 4. So determinant of this one. And what about C32? C32 is minus 1 to the power 3 plus 2, M32. So it is minus 1 to the power 5. It is minus 5. And we will, so this time we will eliminate third row and second column again. So we are left with 1, 2, minus 2, 3. So 1, 2, minus 2, 3. So these are determined, but I didn't tell you what is a determinant of a 2 by 2 matrix. I will give it right now. So how we compute the determinant of a 2 by 2 matrix, we multiply here, so we have the formula. And this is minus, maybe we should have done it for 2 by 2 first. So we have great, but I think we should know it from the high school. So it is minus 8 minus 3 times 4. It is 12. So here minus 8 minus 12. So it is minus 20, but minus 20. So we have 20 here. What about this one? It is 1 times 4 minus 2 times 4. So it is minus 4. What about this one? Minus 1 times 3 minus 4. So we have minus 7 here. But these are cofactors. What is the determinant of A? So determinant of A is given by A12, C12 plus A22, C22 plus A32, C32. But what is A12? So we know A12 is here. It is 0. A22 is 1. A32 is minus 1. So we have 0 here. We have 1 here. We have minus 1 here. And what about C12? We find 20. And we found minus 4, minus 7. So 0 times 20 plus 1 times minus 4 plus minus 1 times minus 7. So we have minus 4 plus 7. So the determinant of A is 3. But we have formulas for. Okay, let me give the formula for the determinant. I should have done the first 2 by 2 matrices, but so let's say that we have 1 by 1 matrix. So what about A is equal to, let's say, A11. So this is a 1 by 1 matrix. What is the determinant of A? So it is just equal to A11. So this is just by the formula, cofactor formula actually. And what about if we have A11, A12, A21, A22? So we have a 2 by 2 matrix. So again, from cofactor formula we will get, so we will multiply these ones, A11, A22 minus A12 times A21. Great. What about a 3 by 3 matrix? So you have A11, A12, A13, A21, A22, A23, A31, A32, A33. So this is a 3 by 3 matrix. Okay, we use the second column. So here we use the second column to compute this determinant. But so if we use the first column, we will have this formula A11, and then we close first column, first row. So we are left with this matrix A22, A23, 32, 3, 3. So A22, A23, A32, 3, 3. And then we have, like this, the formula like goes this, minus 1 to the power, 1 plus 1, 2, 1 plus 3, 3. So minus 1 to the power 3, we get minus 1 plus 3, 4, we will get plus. So we will get minus A12 times, we close the second column, first row. So we are left with these guys, A21, A23, A31, A233 plus A13, and then we will close first row, third column. We are left with this matrix A21, A22, A31, A32. So we have this formula, and there is one formula, so it is called Cyrus rule. We will learn it in the next lecture. So we will learn the Cyrus rule. We have another formula for a determinant. Let me give, so I should have given this one, but first, but what is the determinant of A? As we said, so we have plus sign, and we subtract multiplying with minus 1 times 3. So we have 2 plus 3. So what is the determinant of A is 5. What about if you want to can you find the determinant of A? So this is not defined, right? Because this is a 2 by 3 matrix. So we have 2 rows and 3 columns. So determinant of A is not defined. So is not defined. Determinant of A is defined, or determinant is defined for square matrices only. Is defined for square n by n matrices only. Great. So what about some properties? Okay, whenever you have a determinant, we have some properties. Whenever you have a determinant of a transpose matrix, A transpose, so it is always equal to determinant of A. So recall that we have A is, so from the previous example, A was 1 minus 1, 3, 2, and we find determinant of A to be 5, right? What is A transpose? So we write rows to the columns. So we write 1 minus 1 into the column, 3, 2 into the column, Okay, let's see what is the determinant of A transpose. So this is plus, this is minus. So again, we have 5, right? 2 minus 3. So determinant of A is equal to determinant of A transpose, right? Okay, second property. If you have if there is like zeros, okay, let me write it. If A has a 0 row or column, then determinant of A is always 0. Like if you have 1 1 1 0 0 0 5 2 minus 1, so if this is A, because you have all 0 0 here, if you remember the cofactor, the coefficient, so we always comes from the matrix Aij's. You see, if we choose this row, we will always have 0 times C some cofactors plus 0 times some cofactor plus 0 times cofactor. So we will all and add all those up. We will get determinant of A is equal to 0. Great. The third rule is if you have the determinant of A times B is, we will get determinant of A times determinant of B. So the most important rule is whenever you have a determinant of A times determinant of A minus 1, so this is equal to 1, right? Because we know, I mean, we can get this from the property number 3, because we know that A times A inverse is the identity matrix, right? And what is the determinant of identity matrix is always 1. And if you have determinant of A times A minus 1, so this is by 3, we know determinant of A times determinant of A minus 1, and we know determinant of the identity matrix is 1. So we will get this property 3. Great.